Hi, this is Stephen Brower from Merritt Valley Community College. This is for CSIT 256, Computer Architecture and Assembly Language. And this is to go over the instruction cycle, the steps that an instruction will go through. I didn't want to put it into this video because I didn't want to violate any copyright. But what the slides and Canvas have is a copy of the picture that's in the book showing the instruction cycle. And just out of giggles and grins, I just did a Google real quick, instruction cycle state diagram with interrupt, and other people already violated the copyright by posting it up there, but we are referring to this. Hey, if I Google it, it's legal, right? Okay, so the idea is an instruction cycle is what are the stages that an instruction is in. And so the first thing is, well, we have to fetch the instruction, so the instruction fetch, but it has to actually then, before it does the fetch, figure out where it is in memory. So it has to do the instruction address calculation. Now, the arrow that I'm showing here, imagine if this is the instruction that we're about to fetch. So the instruction address calculation will be figuring out, well, where is this in memory? The instruction fetch, well, imagine if this move EAX apple sold is what it actually then fetches. The next thing is it's going to do decoding of that move statement. And as part of the decoding, it's also going to figure out is that there's two operands. One's the register, which it has. The other one, though, it has to then get it from memory. So the operand address calculation is calculating where is apple sold in terms of memory. In other words, figuring out, that's a pointer to it in order for it to access it. And then the fetch, in that case, is bringing that 8 onto the processor. Now, it wouldn't go, in this particular case, it is actually going to EAX. But depending on what the operation is, it may store it in a temporary location it has that is not addressable for us to reference. But in this case, I will just show, or we can basically say is after that, if that fetch it goes to a temporary place, then the data operation will move it into. So the data operation here will move that value into, in this case, the EAX. After the data operation, we'll figure out, is there anything that has to go back to memory? Well, remember, with the move, the destination is the first part, which is EAX. Nothing needs to go back to memory. So for this particular instruction, there's no need to go and then to do an operand store. If no interrupts came in, it will go on to then get the next instruction. So the next instruction, it'll do the instruction address calculation to figure out where that is in memory, and then it'll fetch it. So the add EAX orange sold would be fetched onto the processor. Instruction operand decoding, it'll try to figure out, well, what exactly is being done here. Well, it knows it's going to have to do the add, so it may have to do some pre-work to say, that soon is going to be, when we get to the data operation, the arithmetic logic unit is going to be doing something. And it is going to figure out that there is an operand. So now the instruction operand decoding is figuring out where in memory is this orange sold, and then the operand fetch. Well, now in this case, it is going to have to temporarily hold somewhere on the processor that 6. So temporarily, somewhere that 6 is being held. Okay. That's the operand fetch. The data operation says we'll add to EAX that value. So that 6 is going to get added to the EAX. We'll then have E. And just to remove it from here, let's just say this is no longer on the processor anymore. Now that we carried out the operation, it's not needed. And then do we need to put anything back in memory? No, because the destination is EAX, so we don't have to do anything for store here. Is there interrupt? well, if you notice, I kept pausing because I keep hearing like a text is coming in, but my cell phone isn't ringing. It's almost like there's another cell phone in my house. Sorry for the interruption. Okay, continue on with this one. The instruction address calculation is figuring out, okay, where is this instruction? And then the fetch will bring that move total sold EAX onto the processor. So in terms of decoding it, it knows, okay, it's going to have to be storing something back to memory. In terms of operand address and operand fetch, there's not a need to do that because EAX is what it has, and we're writing back to memory. That'll be the latter part that we'll take care of. So then the data operation, well, the data operation is that in the store, this value, the E, is going to get put back into memory. So the operand address calculation will figure out where is total sold. So it'll figure out where total sold is. In other words, calculate the physical location where that is. And then operand store, then that E is going to get stored here into memory. And then that's done with the operand store. And so what I was just trying to do here was just trying to relate which pieces correspond to which pieces in the instruction cycle. Most of the things that we are going to see, it's really only doing a fetch of an operand or only doing a store of an operand. It wouldn't be doing both a fetch and a store because we're don't have statements where we can directly move things in a sense from one memory place to another. But so I was trying to illustrate here. So this first statement, move EAX apple sold, it had to calculate operand address calculation, calculate where apple sold was. Then this next instruction, it had to do the operand address calculation to figure out where orange sold was. But on the third one, the operand address calculation is figuring out where total sold was in order to then do the operand store. That's enough for this demo, I think. I gotta find that other cell phone.